the previous class we have started discussing about interfaces. We told that interface is an entity. Okay, interface is one among the three entities. Okay, we have three entities in Java: class, interface, and enum. Okay, so interface is one among the three entities. Okay, class is an entity, interface is an entity, and enum is an entity. Like that, we have three types of entities in Java: class, interface, and enum. Interface is an entity where we can achieve 100% abstractness, and an interface can have attributes and methods. Constructors are not allowed in interfaces. Okay, attributes and methods. We have discussed regarding the methods of interface. We told that the methods of the interface cannot have a body, just because by default the methods of interface are public and abstract, and we cannot have a static method as well as final methods in interface for the reason that by default interface methods are abstract. In order to inherit an interface with another interface, we use the keyword extends. In order to inherit an interface with a class, we use the keyword implements. And using a class, we can implement multiple interfaces. Multiple inheritance is possible in Java between a class and interfaces. Okay? And how we can implement multiple interfaces means just separated by commas. Interfaces will be separated by commas, and the keyword, and the keyword will be implements. Okay, that's what we have discussed yesterday. And today we will discuss some more things about interfaces. Today we will discuss some more things about interfaces. Now, even interfaces can act as reference variables. Okay, even interfaces can act as reference variables. So here I have used my shape as a reference variable. Interfaces can act as reference variables. Now here, what I am doing is, I have interface my shape, interface another, interface test, which extends to my shape and another. This is possible, multiple inheritance is possible using extends keyword between interfaces. Multiple inheritance is possible using extends keyword between interfaces. Now, will it be compiled? Will it be compiled or not? No? Why it will not be compiled? Huh? Calculate? See, from my side we have a method calculate area which is abstract, and from another we have a calculate perimeter which is abstract. This calculate area as well as calculate perimeter will be as it is inherited to test. Now, test has two abstract methods, one is calculate area, one is calculate perimeter. So, these two from test will be inherited to my rectangle. Now, how many abstract methods are there in my rectangle? How many abstract methods are inherited into my rectangle? Two. Okay, calculate area and calculate perimeter. But my rectangle implements only calculate area. So this will be a compile time error. Okay, it shows that it is a compile time error. Okay, now let me implement calculate perimeter correctly and now will it be compiled? Yes or no? Let's consider that the reference is now, can another point to my rectangle? Can another point to my rectangle? Yes or no? Yes, just because another will be a super interface when compared to my rectangle. So my rectangle is a specialized entity for test, and test is a specialized entity for another. So definitely another can refer my rectangle. Now, what is the output here it will print? Okay, whatever it might be. Perimeter is not a method of okay. So since we are executing the calculate area using the reference, it will be a compile time error. It was 100% correct. Okay. See, another is interface, and we can use another reference to rectangle. But if you see here, another interface has only one method, calculate perimeter. So using this reference I can call only calculate perimeter but not the calculate area. So this statement will lead to a compile time error. See, what is S? S is of type another. In another we don't have calculate area. So this will lead to a compile time error. This string like cannot find symbol some calculate area. Now let me make it test. Now will it be compiled and executed successful? Definitely it will be compiled as well as executed successful, just because calculate area as well as calculate perimeter are being inherited to test. So in test both calculate area is available as well as calculate perimeter is also available. So see, in test we extend to my shape and another. So from my shape calculate area will be inherited, and from another calculate perimeter will be inherited. So test has both calculate area and calculate perimeter. So it will be compiled and executed successfully. Okay, now this is executed successfully. Now will it be compiled? Yes or no? No, just because between the interface and the class it should be increments. Now is it compiled? No? Why it will not be compiled? Huh? My shape? Should be? Where? If there is an interface, is it mandatory to implement that? If there is an interface in our .java file, is it a mandatory thing to implement? Where? Where we are calling that function? Calculate? We are calling? Now what do you mean to say is calculate area is not available in test. Am I right? That's perfect. Okay. This will give you a compile time error. Just because we are using a test as a reference. We are using test as a reference, but in test reference we have implemented another, but we have not implemented my shape. But not implementing an interface is not a compile time error. But without implementing an interface, we are using the method inside interface. That is a compile time error. Okay? Not implementing an interface is never be a compile time error. We can or may not implement an interface. But without implementing an interface, what we are doing is we are using the method inside the interface. So this will be a compile time error. See, it gives a compile error just because it doesn't find any calculate area. Okay, now will it give a compile error? Will it give a compile error? Will it give a compile error? Yes or no? It will never give any compile time error. See, not implementing an interface is not a compile time error. Okay, but if you are using a member of interface and not implementing the interface, then it will be a compile time error. Okay. Now let me implement with my shape. Now compile them error. Why it will be a compile them error? The class test implements with another interface as well as my shape. Okay, but see here from my shape and another we have two abstract methods. We have two abstract methods inherited, one from my shape and one from another. How many abstract methods are there? How many abstract methods are there in test? Two. Did we implement any of those two abstract methods? No. So in that case we should make the classes. If we are not implementing any of the abstract methods, okay, if we are not implementing at least one of the abstract methods, then we should make the class as abstract. If there is both extends and implements, if there is both extends and implement, there is both extends and implements, then first it should be extends and then implements. Within the same statement, if we have both extends and implements, first it should be extends, then implements. If we give first implements and extends, it will be a compile time error. If there are both extends and implements in the same statement, then first extends and then implements should be used. So now will it be compiled successful? It will not be compiled successful because of first reason is we should force the abstract keyword for a class. We should give abstract keyword for a class. It will not take by default. We should give abstract keyword for a class. Now, will it be compiled successful? Hmm? Will it be compiled successful? No. Just because test is a abstract method in the class test and my rectangle extends to test, but this method is not implemented. So it will not be compiled successful. Okay. See, the my rectangle extends to test implements another and my shape. So whatever the abstract members inherited from the class as well as the interfaces should be implemented. Otherwise it should be made abstract. Okay? The abstract members inherited from either abstract class or interface should be implemented. Otherwise the class should be made as abstract. So are we correctly implementing the methods from the interface? Are we correctly implementing the methods from interface? Yes or no? Yes. But we are not correctly implementing the methods from the class. So it is a compiled error. Now, will it be compiled? Will it be compiled or not?
Yes.
First, from my shape, what is the method inherited? What is the method inherited? Calculate area. So, after compilation, the interface from the method from my shape will be a public abstract, okay, double calculate area, okay, and the method from another will be double calculate perimeter, and after compilation the method in test will be the same, it will not change. Now for the first method, do we have any implementation in the current class? Yes, the calculate area is public, double double, and the same name calculate area and the same list of arguments. That's fine. For the second method, calculate perimeter, yes we have. And for the third method, do we have any implementation? For the third method, do we have any implementation in the current class? Yes or no? For the third method, do we have any implementation in the current class? Yes or no? For the third method, do we have any implementation in the current class? Yes? Yes. Which one? First or second? First method. First method is already an implementation for the abstract calculate area which is inherited from my shape. Then how the first method can be implementation for the third? First method is already a implementation for calculate area which is inherited from my shape interface. Now for this, where is the implementation? Hmm? Where? Definitely it will check. Yeah, definitely it will check. The compiler definitely it will check whether it has implemented, it has been inherited from the first or second. It's not like the compiler will not check. But any other reason?
Yeah, exactly. Means actually it is default keyword. So we can define it with default keyword or for public. So we are writing for
You are
public.
telling about the overriding rules. If we consider the overriding rules, then this is perfectly implementing this method. But what my concern is, already this method acts as the implementation for the first one, which is inherited from myself. So, can this method act as implementation even for this method or not? That's the concern. Definitely yes. A single method can act as a implementation for multiple abstract methods. A single method can act as a implementation for multiple abstract methods. That is possible. A single method can act as a implementation for multiple abstract methods. A single method or a single concrete method. A single concrete method can act as a implementation for multiple abstract methods. A single concrete method can act as a implementation for multiple abstract methods. If that is the rule, then will it be compiled successful? If that is the rule, will it be compiled successful? Yes? Yes, definitely yes. Just because for the first as well as the third method, this is the same implementation. This method can act as the implementation for both the third as well as the first method. The method inherited from test as well as method inherited from myself. So, this will be compiled successfully. A single concrete method in the subclass can act as an implementation for multiple abstract methods. Okay, that's possible. Understood? Now will it be compiled successful? Will it be compiled successful? Yes or no? No. Those who tell yes, please raise your hands. This will not be compiled successful just because while implementing a method from an interface, definitely we should use public keyword. Just because interface methods will be public by default. Interface methods will be public by default. We told earlier clearly that interface methods will be public by default. By default, interface methods will be public and abstract. So, while implementing the interface method, we should use the public keyword. While implementing a interface method, we should use the public keyword. That even we have discussed this in the very earlier examples. Okay, while implementing a method of interface, we should use public keyword. Now it will be compiled. Okay. So ensure that you are using public keyword while implementing a interface method. Now let's consider that I have calculate area and calculate perimeter. I have calculate area and calculate perimeter. Now will it be compiled successful? Yes or no? No. Why it will not be compiled? Just because test test should be abstract. Why test should be abstract? It has two abstract methods, calculate area and calculate perimeter. Is any of the abstract methods correctly overridden? Is any of the abstract methods correctly overridden in test? Yes. Calculate area is correctly overridden in test. But calculate perimeter is not overridden. Now, can we restrict? Can we restrict or how can we restrict calculate perimeter from inheriting to test class? See, by default, calculate area as well as calculate perimeter will be inherited to test class. But how can we restrict? How can we put some restriction so that only calculate perimeter should be inherited, only calculate area should be inherited to test. Calculate perimeter should not be inherited to the test class. Private? Just rewind the notes. Is it possible to keep a access level other than public in interface? It's impossible to have other access level than public. Okay? The only access level that is allowed in interface is public. And what my question is, how I can restrict only calculate area to be inherited to the subclass. Calculate perimeter should not be inherited to the subclass. Final methods will be inherited. I did not tell that final methods will not be inherited to the subclasses. Final methods will be inherited to the subclasses but should not be overridden. It's a good answer. Okay? It's impossible to put some restrictions on inheritance. Any method or any attribute which is non-private will be inherited. We cannot put any restriction on an attribute or a method from inheritance. Okay? We cannot put any restriction on an attribute or a method from inheriting. All non-private members, all non-private attributes and non-private methods definitely will be inherited. We cannot restrict them. All non-private attributes and non-private methods will be inherited. We cannot restrict them. So definitely it will be inherited. Now you see here, is a dot class file generated for interface? Now how many interfaces are there in my class? Sorry, in my .java file? In the .java file, how many interfaces are there? One, my shape. Now is there a dot class file for my shape? Yes, definitely for all the entities dot class files will be created. Even for interface, a dot class file will be created. And there is no constructor inside interface, so constructor interfaces will not participate in constructor chaining. Interfaces cannot have instance installation block, static installation block, or a constructor. The only possible members in interface are attributes and methods. The only possible members inside interface are attributes and methods. Okay? And can we create an object to interface? It's impossible. It's impossible to create an object to interface. It's not possible to create an object even for abstract class. Okay? And how it is possible to create an object to interface which can be 100% abstract? Okay? So it's impossible to create an object to interface. And interfaces are by default abstract. See, we need not to keep abstract keyword for interfaces, but will not give any compile time error if we put this, but it's not required. Interfaces are abstract by default. Okay, we need not to put an abstract keyword for interfaces, they are abstract by default, but putting an abstract keyword will not give any compile time error. Then the attributes of interface. Okay, the attributes of interface are by default public, static and final. The attributes of interface are public, static and final by default. And interface attributes are used as constants. Interface attributes in general they are used as constants. In general, if you want to put all the constants in a separate file, in a separate entity, that entity will be interface, definitely. If you want to put all the constants in separate entity, then that entity will be an interface. Now, So just because they are static and final attributes, for all the static and final attributes, the naming convention is there will be an uppercase, and if there are multiple words, then multiple words are separated by underscore. This is the naming convention for interface attributes, just because they are static and final. The naming convention for static final attributes are they will be in uppercase and multiple words separated by underscore. Just because interface attributes are static and final by default, now let's consider that how I can access interface methods. Can I access interface methods like this? Can I access interface methods like this? Can I access interface attributes like this? My shape.py value? Yes, just because they are static. They are public and static and final by default. So, if you try to compile, it will be compiled successful. Go to classes, execute this. This will be executed successfully. So, interface attributes are static and final by default. Public, static and final by default. So, other access levels are not allowed. If you keep protected, if you give any access level inside interface other than public, then it is a compile time error. If you keep any access level other than public inside interface, then it will be a compile time error. If you keep protected, then also it will be a compile time error. The only access level that is allowed in interface is public. Either for attributes or methods. So, modify protected, not allowed here. Now what's the value printed? Will it be 3.14 or 4.15? Will it be 3.14 or 4.15? It will be a compile time error, definitely. Just because what we have discussed is interface attributes are public, static and final by default. So final attributes should not be redefined. So interface attributes cannot be redefined. Interface attributes cannot be redefined. Okay. Now let's consider that I'm not defining any value here. Now will it be compiled successful? Yes or no? The attributes of the static final attributes, where we can define static final attributes, either in the place of declaration or static installation block. Now, do we have any static installation block in interface? No. Where is the possibility to give a value to an interface attribute? Definitely, interface attributes should be initialized. Initialization means giving a value at the place of declaration. Giving a value at the place of declaration is initialization. So, interface attributes should be initialized. That means at the place of declaration only we should give a value to a interface attribute. There is no other possibility. We should give some value to a attribute of interface only at the place of declaration. Only at the place of declaration we can give a value to a attribute of interface. Okay? Just because interface attributes are static and final by default. Static final attributes can be given a value either at the place of declaration or inside static installation block. There are only two possibilities. But among those two possibilities, static installation is not valid for interface. It's not available for interface. So the only possibility to give a value to interface attributes is at the place of declaration. Only at the place of declaration. Now, can we call this interface as 100% abstract? Can we call this interface my shape as 100% abstract? Yes or no? This interface is never said to be 100% abstract just because there is a attribute. Attributes cannot be abstract. Okay? This is not a 100% abstract entity just because there is an attribute. And if there is no attribute inside the interface, then that will be 100% abstract. If there is no attribute inside the interface, then it will be 100% abstract. Now, what is the difference between abstract class and interface is a very, very important question for interviews. Just list out your own differences between abstract class and interface. What's the difference between abstract class and interface? List out, I'll give you a couple of minutes. Just list out the differences that you know between abstract class and interface. And previously, the difference between method overloading and overriding. That is also a very important question for interviews. The difference between overloading, overriding, abstract class and interface. No. The abstract class can have 100% concrete members. That's one of the differences. Reference. We can use interface as references. We can use interfaces as reference variables. Definitely, that we have used several times in the previous class also, right? Just list out all the differences. We can discuss one by one. Now, over. Still, you can take a couple more minutes, but over. Now, what's the first difference between an abstract class and interface? What is the first difference? What is the first difference between abstract class and interface? Abstract class? A class cannot be 100% abstract. Okay. Some people will ask the differences between abstract class and interface. Some people will ask the difference between class and interface. Okay. See, based on the question, you need to add some points. Okay. If they ask the difference between abstract class and interface, the first difference should be abstract class is not 100% abstract, but the interface can be made 100% abstract. Abstract class can have both abstract as well as concrete methods. Abstract class can have both abstract and concrete methods, but concrete methods are not allowed in an interface. And abstract classes can have constructors, but constructors are not allowed in interfaces. At the same time, even initialization blocks also. Constructors and initialization blocks are allowed in abstract classes but not in interfaces. Constructors and initialization blocks are allowed in abstract classes but not in interfaces. The default level of access level for members in abstract class is package. The default access level for members inside abstract class is package. But the default level access level for members in the interface is public. And for abstract class, we should specify the keyword abstract. For abstract class, we should specify the keyword abstract. For interfaces, we may or may not specify the abstract keyword. For interfaces, we may or may not specify the keyword abstract. That doesn't make any difference. Whether we keep abstract or not doesn't make any difference for interfaces. By default, interfaces are abstract. And the methods of a interface are public and abstract by default. But abstract class methods are not public and abstract by default. And the interface attributes are public, static and final by default, but it's not there in the case of abstract class. The interface attributes are public and abstract by default, but it's not in the case of abstract class. The interface attributes are public, static and final by default, but it's not there in the case of abstract class. Fine? Oh? Now, this will complete the concept of abstraction. And this will complete the concept of object-oriented programming concepts. Okay? And the next is package and access levels. It will take at least 2 classes. So, I don't want to break just because we have a long vacation. I don't want to break that classes so that you will be confused. After coming next week, you may be confused like what is access learning now. So to avoid that confusion, I am stopping the class here, and in the next class I will discuss what is packages and what is access levels and what are the different access levels and why the specific access level is used and all. And the next class will be Monday at 7 o'clock. Just I will be returning from home, so it will become a little bit late to come to university. So the class on Monday it will be 7 o'clock, but the remaining classes will be 6 o'clock only. Only on the next Monday the class will be at 7 o'clock. Okay? Have a long weekend. Enjoy the day.